In this lecture, we're going to start exploring how we can build iterator support for our custom containers that we build ourselves. And we're going to be using our box container class as a use case here. Now, again, please remember this iterator hierarchy. Some algorithms are going to need different iterators. For example, the sorting algorithm we have had a chance to look at requires random access iterators, while the reverse algorithm might require a bidirectional iterator. So each algorithm is going to need its own iterators. And to know, you kind of have to go to CPP reference or a similar piece of documentation to figure that out. Now, there are a few things you need to keep in mind if you want your custom container to support iterators. And the first requirement is that your container needs to be a class template. Because if your container kind of works on a single type, it's really not generic. So the standard library won't bother working with your container. You need to make it generic, and you make it generic by using class templates to make it work. The container class also had to model iterators, and these are iterators that are going to be looked for by the algorithms that work with your collection. And your container will need to provide the begin and end methods at least to be able to work with all these algorithms here, because they're going to be using this method to get your iterators and work with them. And the last thing that should be clear is that different algorithms are going to need different iterators. So you have to kind of make sure that the kind of iterator provided by your collection is what the algorithm you want to use needs. And we're going to look at a few examples of this. Don't worry if all of this is not making sense yet. Now, we're going to model our iterators as nested classes, but you don't have to do it that way. That's just the way I am going to use to show this to you. Once you understand the concepts, you can do all kinds of crazy things. Your iterator class is going to need to provide type aliases that are expected by the standard library. And this is a thing I found out the hard way through experimentation when I was learning about how I can provide my own iterators for my own containers. And I am going to show these things to you here. And these type aliases are going to help our algorithms work better. For example, the algorithms can look at these type aliases to know if we have the kind of iterators that are needed by these algorithms. And if our iterator doesn't provide what is needed by the algorithm, it's going to be directly discarded by the algorithm, and the standard library is going to look for other things. If it fails to find what it needs, it's probably going to throw a compiler error somewhere. Okay, so here is a simple example of the first step we need to take to build iterator support for our box container. We're going to set up a nested class in our box container class. That class is going to be called iterator. You don't have to call it iterator, but I am going to call it iterator here to make it easy to spot. And one thing you need to provide in this class is a bunch of type aliases that are needed by the C++ standard library here. We need iterator category, which is going to specify what kind of iterator this class iterator is providing. We need to model difference type, which is what you get when you subtract an iterator from another iterator. So this is really going to be wrapping around a pointer to our type that we have in our box container. So subtracting two iterators is really going to give us a pointer difference. That's what we have right here. You need to model value type, which is going to give you the type that your collection is storing. And in this case, it is storing T because this is our class template here. We need to model a pointer type, which is going to be a pointer to our type. We have that right here. We need to model a reference type, and we have that right here. Nothing really complicated. These are just standard type aliases that are expected by the standard template library. Once we have the iterator class, we will need to provide a begin and end method. And notice that we are returning these iterators here through a bunch of constructors we haven't seen yet. I am going to show you this to you in a few slides ahead, but you need to provide these two methods here. Once we have this, we're going to look at some of the other operators we need to provide in our iterator. In this case, we are really trying to model an input iterator through which we can read. And the reading is going to happen through these two operators here. You can either use the dereference operator or you can use the pointer access operator here. We also have a bunch of constructors. We need a default constructor because this iterator is going to be used in all kinds of crazy places. So we're going to provide a default constructor here. And we have another constructor we're going to be using ourselves to build iterators that we need. And it is this constructor we are using in our begin and end method, as we see right here. So we are calling this iterator and providing the pointer it's going to be wrapping around. We are going to also provide a bunch of operators because our iterator needs to move forward. So we're going to provide a plus plus operator. We're going to provide another plus plus operator, which is going to be a postfix version of this. We are also going to provide an equals equals operator and a not equals operator because we need to be able to check an iterator against another. And this is going to be useful when we need to check when we have reached the end of the collection if we are looping through the plus plus operator here. Believe it or not, once we have our iterator class here, it is going to be ready to be used by some of the built-in standard algorithms. For example, we can set up something like this. We're going to set up a box container and it is going to be populated with data as we see here. And once we have this, we can use the find algorithm to find stuff. And please notice how powerful this is. We built our own container and it is able to work with the find algorithm that was designed without any knowledge about our container class. And this is really the idea about the STL. It is highly flexible. And once you provide these iterators, your collections are going to be usable with a range of algorithms. And that's going to be really good for your collection here. Now, another thing that we're going to be able to do is for our collection to work with a range-based for loop. I don't think many people care too much about this, but when you use a range-based for loop like this, the compiler is going to generate another piece of code which is going to be using iterators behind the scenes. And once we hit Visual Studio Code, I am going to show you this through CPP reference. You're going to see the code that the compiler generates for you, and you're going to see that iterators are going to be used behind the scenes. So now that we know this, we're going to head over in the next lecture and set up an input iterator for our own collection, and that's going to be really cool. So go ahead and finish up here and meet me in the next lecture.